Alright, so here we're going to be talking about verifying right triangles. Basically, we're going to be testing triangles to see if they are, in fact, right triangles, if they have a right angle. We cannot just judge based off the picture. If the picture actually has the angle marked with that little box in the corner, that tells us it's a right angle. If it just generally looks like a right triangle, where maybe that is a right angle, but it's not labeled, we will never just trust that picture. We don't trust our eyes there. We're going to use Pythagorean theorem to test it. If it works in Pythagorean theorem, basically, if you can plug in the A, B, and C, and one side of the equation, A squared plus B squared, actually does equal C squared, then it's a right triangle. So we're just testing to see if a given triangle with the three sides that we see would actually make sense in this formula, making it a right triangle. If it works in Pythagorean theorem, basically if this side actually equals whatever C squared is, then it is a right triangle. So we want to decide if this is a right triangle using Pythagorean theorem. Again, we are not trusting our eyes. That does look like a right angle, but it's not marked there, so I'm not going to trust that at all. I'm going to use Pythagorean theorem to test it. A squared plus B squared equals C squared. The biggest thing is identifying where the right angle might be. So it might be there. The easiest way to tell which one your C has to be is really just from the longest side between these three. That has to be our C. It also would be across from that right angle there. That's the longest side, so it has to be the hypotenuse. The A and B actually can be in either of these two spots. I just like writing it in order from least to greatest. That's the small one, the middle one, and then the big one. So small, middle, big. So now I'm really just going to test this to see if this actually makes sense. I'm going to square 12. That gives me 144. Square 18. That gives me 324. And then I'm going to square 22. And that gives me 484. So I want to see if this is a true statement. If this side actually does equal that side. 144 plus 324. These two added together. Oops, I don't know why I wrote a 3 there. Sorry, it's 468. And that is supposed to equal that side, but it does not. Since those two are not equal, this is not a right triangle. So we're looking for two different things. If these two are not equal, this could be any number besides that. That means it's not a right triangle. If these two are the same, that means Pythagorean theorem is verifying that it is a right triangle. All right, so we got another example here. We have two legs of 50 and 120. I'm going to label this as A. This is B. I know this has to be C because it's the longest side. It's also across from or opposite what I think is going to be my right angle. So I'm just going to test that using Pythagorean theorem again. A squared plus B squared equals C squared, or at least if it's a right triangle, it will. So A squared, I'm going to use 50 as my short side, and then my middle side is 120. That's going to be my B squared. And then 130 will be my C. So I'm going to square each of these just to simplify this and actually see, does this stuff really equal whatever I get from squaring that 130 on the right side? So this would give me 2,500. This would give me 14,400. This would give me 16,900. So that's just from multiplying each of those together twice. When I add these up, I get 16,900. And that's exactly what I had on the right side. Those two are equal, so this must be a right triangle. So again, we're really just using this equation to test to see if those two sides are in fact equal. If this side equals that side, it's a right triangle. I'm going to do a couple more examples there. We see we have a different orientation, but it doesn't really change the problem. I'm still just looking at my longest side as C. I'm going to call my shortest side A, and then the middle side I'll call that B. So that's 8 squared plus 15 squared, A squared plus B squared. I'm hoping that equals C squared, or 17 squared. 8 squared is 64. 15 squared is 225. 17 squared is 289. And these two added together equals 289 also. So this is what I'm testing. I want to make sure that my a squared, my two short sides, my a and my b, squared and added, actually gives me the same thing that I got from c squared. Since it does, that's a right angle, and this is a right triangle. All right, one more example. Now I'm looking at, maybe this is my right angle. I know that that has to be my C, so this would be the right angle. That's got to be the longest side. It's bigger than the 35 and the 12, so my C is going to be 36. My A, I'll call that 12, that's my short side, and then B, I'll say that's 35. So A squared plus B squared, and we'll see if that actually does equal C squared. So that's going to give us 144 from 12 squared. 35 squared is 1,225, and 36 squared is 1,296. So I'm going to add these two together and see if it actually does equal that. It won't. It's going to equal 1,369, which is not equal to what c squared gave us, so this is not a right triangle. So again, you're really just testing using the Pythagorean theorem. If these two sides are equal to each other, it has to be a right triangle. If they're not equal to each other, like we saw here, that is not a right triangle. So these are really just yes or no questions using that to test to see if it is a right triangle.